Our main goal while building the architecture was to make incremental updates, or the performance of incremental updates, independent of upsize. So it should always be constant in performance, and it doesn't matter how large your application grows.
Remember, the full episode is only available to our Patreon members. Hello, welcome to the DevTools-fm podcast. This is a podcast about developer tools and the people who make them. I'm Andrew, and this is my co-host, Jess.
Hey, everyone. Our guest today is the one and only Tobias Koppers. Tobias is the creator of Webpack, now TurboPack. Tobias, we're really excited to have you on to chat about what you've been up to at Vercel. But before that, would you like to tell our listeners a little bit more about yourself?
Yeah, hi, my name is Tobias, and I'm from Germany, from Bavaria, and a little town. And yeah, I'm working on maintaining Webpack like since 10 years, for 10 years now. And like 2 years ago, I joined Vercel and started working on TurboPack. So just bundling stuff.
Just Bundles is playing it down a little bit. Webpack has been such a huge tool in our industry for the past decade, but I think some of our viewers might be surprised how it came about. So could you fill us in on how you started Webpack?
Yeah, it's funny story actually. When I did my master thesis, I did a web application as master thesis, and for that I was looking for like JavaScript tooling. I wasn't into JavaScript at all at the time, so I just looking around, just looking for a bundler, or basically a tool to like optimize my application. I was a little bit into over optimizing stuff, maybe because it's a master thesis and you just do that. And yeah, so I found a bundler which was called modules web make, and I proposed this feature named code splitting. Before doing studying, I worked with GWT, which is Google Web Toolkit, which is a Java to JavaScript compiler. And yeah, you probably expected from my Java to JavaScript compiler, the bundles end up to be really large. And it has this great feature about like splitting your application into like some code being loaded on demand. And I was missing this kind of feature in the JavaScript tooling I was working with. So I proposed it, made an issue on this bundle I found, like modules web make, and basically proposed that. And yeah, there was some interest. But in the end, I ended up implementing a prototype by re-implementing the whole bundler. And basically this prototype was then renamed into modules Webpack, and then Webpack, and basically developed as its own tool now. I think the issue is still open, so yeah, it's funny. And the story continued a little bit. It was really small tool. I had a few people writing issues, using it a little bit. But the larger success was when like Pete Hunt from Instagram.com met this, I think on OSCon 2014 or so. He made this talk about how Instagram works and basically promoted Webpack as tool they're using. And I think there the success of Webpack started and more people gaining adoption. I think I was a little bit lucky with that. I hit like the right thing at the time because I was over optimizing this kind of bundler and a little bit like code splitting. You probably at that time you probably don't need that feature because applications was like 1,000 or maybe hundreds of modules, so nobody needed that. But this was really cool, but the web development in general growed, and applications become larger, and so code splitting ended up to be really useful for that kind of development trend in web development. And I think that was like the major success point of Webpack. Maybe another thing was like that we focused on extensibility and flexibility, which was also useful in the growth of web applications in general, because we experimented a lot with different technologies, whatever TypeScript flow, all this kind of stuff that were developed at this time. And I think the flexibility of Webpack was a really huge point at that time, and I think still is.
Yeah,
Absolutely.
yeah. It's cool how it came out of such a small use case. Like you started as an issue and was just like trying to solve this one tiny little thing, and now Webpack is like it's so all encompassing of all different like ways you build your application now. So you touched on extensibility for a little bit. What was your guys' initial approach to extensibility? Because from my perspective, what Webpack has today is like, even though it's a very, very big plugin API surface, it's so flexible and allows for so much creativity.
Yeah, the thought about flexibility was that my idea was about like the tooling also was that like it's often used in companies, and companies have these kind of super special cases. I think every company has this kind of, yeah, I'm special in that way, or I have this legacy code that need to be integrated. And that was my motivation behind like the flexibility of Webpack, that I wanted to solve like all these edge cases that people have in their company application or whatever, and all this legacy stuff. I just wanted to give them the opportunity to use Webpack by like providing at least the tools to build something to integrate the stuff they want to have in a bundle or in a tool. So that was like the idea behind that.
That's really interesting. I think a lot of times when people are approaching projects, they're like, all these edge cases, they're like, this is all out of scope. Like, we don't even want to think about this. It's like, want to really narrow down, but it's like explicitly saying, okay, I want this to be flexible enough so that you can target your own edge cases is kind of a really compelling case. And I think that like, especially as Webpack has developed over the years, it's been sort of it's been such a great example of how to build like a really good plugin architecture, for example, for sure. I know Andrew has used the sort of similar like plugin architecture that Webpack uses.
Yeah, I love Tapple. I've used it in probably like 3 or 4 different projects now.
Yeah, it's really cool. Yeah, maybe even like Webpack's API surface is too large in some cases. Like it's a kind of, it can become a problem, because like you have this really large plugin interface, and plugins can do anything, but it also means like anything is part of your everything is part of your like API and part of your semantic version and API surface. So if you want to make refactorings or changes in that kind of things that plugins could access, it to almost end up to be a break and change for something. So it's really hard. In many cases it can make it harder to like iterate on larger changes or larger refactorings, especially if you want to avoid breaking changes, which people dislike.
The ease of use of the plugin system is definitely a double-edged sword. It's like, oh, look, we can give all these features to the developers, but then the backside of that is, oh, well, man, I need to support this hook that wasn't the most well thought out forever now, which is a lot to carry.
Yeah, but yeah, I think it's like a trade-off between flexibility, extensibility, and maybe migration story, and like bringing changes and major versions. Yeah, that in the past it turned out that like often Webpack major versions were really hard, or like harder than usual to like migrate on, especially as like plugins need to be upgraded. Yeah, so we can control like the configuration a little bit, but like plugins, it's always it often needs some attention from like maintainers of plugins that may or not be there anymore, and it can be hard.
Yeah, when your migration story becomes a community effort, then it like definitely increases the complexity. I was reading an interview that Richard Hipp was given. Richard Hipp is the creator of SQLite, and he was saying that like SQLite was sort of like this accidental problem. He's like solving something for a customer, and he's like, oh, I just need like a database on disk, and so he created that. And he's like, it was a lot harder than I thought it was going to be. It's like I thought it was going to be not that bad. And I'm curious, was Webpack like the problem? Did it become like a lot more? Was it like a lot more difficult than you anticipated when you like first started diving into it? And like how has that sort of changed over time?
I think it was initially when I made the prototype, it was, I think, easier than expected. Like it was really easy to like make a really simple bundler which can like deliver that one feature. It's like I think it has become harder over time when you add and more features and all the stuff, and then you have a lot of test cases, and you want to change the one thing and it breaks the other thing, and yeah, you probably know that. I think like the small initial bundle was really easy, but like, and then the interaction of many features becomes the problem. When like, yeah, especially if like because of the flexibility, like people use this configuration with that configuration, and then in this kind of weird combination it breaks, and I think then it becomes really hard to add or change a feature while keeping all the other features intact and working as expected, even with like people using it in unexpected ways and stuff like that.
Yeah, so touching on the success of it a little bit, has that success been hard? Like, were there things that you wanted to do with Webpack that because of the success and because of the way the project went, you just couldn't accomplish?
A good question. I won't think so. Like especially like I didn't. I don't really know. I wouldn't say. I would say no. It wasn't like not that the success hindered me in doing something special, something what I wanted to do. Like I was more. I think that most of the time working at Webpack, I was not really driven by my own use case, because my own use case vanished like after a short while. But like I was more like motivated or like driven by community feedback, and like worked with a lot of people at the start, looking at what their use cases are. I was just doing this project for fun at the start, so I wasn't like I didn't have any special goal with it. It was just like I wanted to build something cool and want to like make the people happy that using my project, and yeah, it was kind of that was the motivation. And I think that with that motivation, my goal is to make the community happy, and like so the success I think is more like a good factor in this case, and not like a blockade.
Let's talk about a little bit forward looking. So Vercel announced TurboPack, which is, from my understanding, the next generation of Webpack. Could you tell us a little bit more about like TurboPack and what it is and what its purpose is in the ecosystem?
Yeah, I can start with the motivation of TurboPack. So yeah, Webpack is like 10 years old, so it's and I told you that like it is hard to iterate on the like larger refactorings and the stuff. And one major problem of Webpack, or maybe not a major, but it's a problem of Webpack, is that like it's kind of the performance is a little bit problematic in some cases, especially if you grow really large with your application. So it works well, but if you have like multiple thousands of modules, then you cannot end up with multiple seconds of incremental compilation, which is technically still pretty fast, but user expect like sub-second of updates and stuff like that. And yeah, that like one motivation was this performance aspect, which is really problematic in Webpack, and we wanted to change that, and we wanted to fix that, and we fixed a lot of performances, so we made it a lot faster, but we hit it like a point where we like couldn't optimize it anymore without like refactoring the whole architecture. So like the underlying architecture was a problem, but we can't really change that without like breaking every plugin and every user, and that is not something we want to do. And I think that in this case, creating a new name and a new product, which is like based on the same ideas of Webpack, but like with a different architecture and different plugin system, and is better than like making a Webpack 6 or 7 or 10 or whatever that breaks every user with a completely re-implementation of everything. And then it's clear that you can't like it's more expected that you have to migrate to something than like it's more than a major version or break and change of something. And another motivation was also like there was three kind of major motivations. So performance was one, and basically in Next.js we use Webpack, but we not only use one Webpack, we basically use I think 4 or 5 compilers of Webpack just to make like client compilation, server compilation, server-side rendering compilation, server components compilation, and basically like we needed a lot of compilers to orchestrate the stuff and basically let them communicate together. And it's error prone. It's also hard to implement, and you have to care a lot of edge cases and race conditions and stuff like that. So we also made this kind of major change in TurboPack that we wanted to have like the module graph and cross environments, so you can like just import modules between environments, and you basically have all the different modules of different environments in one single module graph, which make a lot of things easier and also like having new opportunities about like optimization, like between environment optimization. Like you can, if you use only some properties of a client component then in a server component, then we can optimize something like that. And there's more about that. But that was one of the ideas, and we started this project on top of like a completely new architecture that was like designed with the goal of incremental compilation first. So like we made everything just to make like incremental compilation as fast as possible, to not only to like fulfill like the subsecond goal for the current applications, but you have to think like Webpack is 10 years old, but we also write a new tool. We want to like aim for being alive at least 10 years. And if you like think about the next 10 years of web development, how large application is going to be, probably pretty large. So we want to have like something that could work within like hopefully 10 years. Not sure what happens there, but so we really designed it to really our main goal by building the architecture was like to be to make incremental updates, or the performance of incremental updates, independent of upsize. So it should always be constant in performance, and it shouldn't matter it doesn't matter how large your application goes. So if you have hundreds of modules, 1,000 modules, or 10,000 modules, update speed should be constant and only like affected by the size of the update and not by the size of the application, which is the case in Webpack, where you have this kind of management overhead for just getting all the modules from the cache and stuff like that, which scales by application size. So that was like the driver behind like the new architecture of TurboPack. Yeah.
So to go faster, is it relying like on ES modules more? Because like a big tool right now is Vite, and a lot of the core fastness of Vite comes from the way it uses ES modules.
Yeah. So I can explain why. So basically Vite. So usually we build. So Webpack is a bundler, but Vite like is more a non-bundler. It's like it's a similar space, but it's technically not a bundler because it doesn't. It's like more hybrid, but focus on the non-bundling aspect. So it's a non-bundler for your application code, where it doesn't really bundle your code into larger files and then ships these files to the browser. Instead, it basically ships your code per module of your code like unbundled, so just as raw code, maybe transformed a little bit to the browser, and lets the bundler lets the browser take over basically with its own module system, ECMAScript modules. It lets the browser make the work of connecting all the modules together and like not bundling them, but like bringing them together into like one execution. So that makes it really fast for incremental updates, because you usually a bundler has to rebundle your application and then like sends a new bundle or sends the update bundle. And basically bundling aspect and all this like work that happens with the module graph, it is scales by application size, and the chunk graph, it scales by application size. Vite or non-bundler in general don't have to do that. It just sends you modules. It's basically a simple or kind of a simple server which you ask for a module and it sends you a module, and the browser only in the browser the modules came together into a module graph, which in case of updates, it only has to like process one module and send it back to the browser, and it makes it really efficient for like really fast updates because it doesn't have to do this kind of management overhead of a bundler. And you asked if we do that, and actually we do not do that. So TurboPack is a bundler. It's not a non-bundler. So it's the same kind of thing that Webpack is basically. But we implement it in a way that it's like due to the new architecture that it's as fast as a non-bundler by making some kind of tricks like this kind of incremental compilation thing. And we also we don't bundle if you make an update. We basically only send you the one module you changed to is affected by the change via WebSocket, and that makes it updates as fast as a non-bundler, even while we are bundling in total. But why? It's a good question. So basically, a problem of non-bundlers is it's the initial startup. You have to send if you have 10,000 of modules in your application, you have to send 10,000 of requests from the server to the server, from the browser to the server, just to get all the 10,000 modules. And basically by not bundling, you basically get this kind of lot of requests, and that's basically the reason why we bundling for production is to reduce the number of requests, send modules in a more efficient way, and it also makes sense, why not that hard of a limit, to make the same kind of thing during development, to just send it more efficient to the browser. And especially if you scale larger than these kind of 10,000 modules, requests can become really problematic. Especially if you have DevTools open, which is really not really efficient in handling that many lines in the network tab. So and there were also some other reasons why bundler are different and why we choose a bundler. And another reason was HMR, that because in a non-bundler, the browser basically owns the module system. So it's a JavaScript module, so it owns it. So you can't really what usually HMR does in Webpack is that it just sends you a new module, then it replaces the module in the module graph. In non-bundlers, when the browser owns the module system, you can't replace a module. It's immutable in the module system. There are some hacks or workarounds to get a new module, like a timestamp, and then you have to reconnect the stuff. And it's not the native HMR way of just replacing the module in the running application graph. So that is another reason why we choose to make a bundler. And the third reason was that basically it works great for development, but in production you still have to bundle something. And now you have this world where you have ECMAScript non-bundled in development and then production bundled with a different tool in production. And so we don't want that. We want to have production and development as similar as possible to rule out the problems of production only things and weird things that behave only in development or production. Different environments in development and production can be a problem in some cases. And that's why we're trying to make TurboPack a bundler. And we also wanted to improve the speed of production builds, and that a non-bundler approach or a ECMAScript approach doesn't help us for that. So we want to have faster builds and faster dev mode, and that's basically the reason why we choose a bundler. So if we would have to choose a non-bundler, we basically would have to implement a non-bundler for development and a new bundler for production, and that's kind of duplicate work. And if we can make it a bundler as fast as a non-bundler, then we are happy with that.
So you've learned a lot over the years of working on Webpack, especially. Are there assumptions that you can make now to improve how bundling and tree shaking work that, fundamentally Webpack didn't allow previously?
Yeah, I wouldn't say assumption, but there were some things that didn't exist at time of writing Webpack, like ECMAScript modules or TypeScript or like all this kind of optimization opportunities. And I think with the knowledge that I have now that these kind of things exist, and we basically settled on ECMAScript modules and also kind of settled on TypeScript, and we settled. I think that the technology space is in general more settled down on a few technologies that are really mainstream, and few things disappeared like CoffeeScript or all these kind of other things. And yeah, I think there's more clearness in the web application development world, so we can make a lot more assumptions about like these as the tools that you probably use or that you want to use, like TypeScript. So TurboPack ships with TypeScript support by default. So that's kind of one assumption we can make, that either you want to use JavaScript or TypeScript, and maybe there's something in the future, but at least we can say TypeScript is something you probably want to use. And in Webpack, like I think TypeScript didn't exist at the start of Webpack, but also Webpack was like it's really low level in kind of sense, so it doesn't ship with a lot of defaults, mostly because we didn't, TypeScript didn't exist, and there was also Flow, and like the community wasn't like hadn't chosen one of that, and it's the same with many of these technologies, and so that was kind of things we can do better now. And with ECMAScript modules, like before there was only like CommonJS and AMD, which were really dynamic technologies, so it didn't have this clear definition of this is an export and it's how you use it. It was more like you get an object and then get the properties from the object, and it's like you can make really dynamic ways. And with ECMAScript modules, we have this clear export definition, and it's more statically analyzable compared to CommonJS. And with this knowledge, or basically by knowing that the module system is really static and analyzable, you can build something. You can build on top of this and make more optimization on like OneUp, like pioneered on that kind of space where they use ECMAScript modules and they are statically analyzable module system format to make more assumptions about or make more optimizations, which so Webpack wasn't designed for that, because like at this time it didn't exist, and it was not clear, or it was not expected that there was something statically analyzable in the future. We still implemented something which kind of goes into this direction, like tree shaking, but I think there's more opportunities. There are more opportunities to optimize even further, and we have some plans for TurboPack to like get more out of like the ECMAScript module format and optimize further, which was like not happening for Webpack because it was just too complicated. But it was also not happening for Webpack because it wasn't just. It's really performance intensive to like implement that kind of thing. So the basic idea is to like currently we have modules as lowest level of optimization. So we move them around, we can skip them, we can maybe shake some export of that. But in TurboPack for production, we're planning to like make statements and declarations the lowest level like of optimization. So instead of having a module graph, we basically have like module fragment graph where each statement or each group of connected statements is one module fragment in the graph. So you have basically your module graph grows by the factor 10 or 20 just because it's like split into smaller pieces, and these kind of more granular pieces allow you to optimize more cleverly, like put one part of a module in one chunk and put another part of the module in another chunk, and the shared part into a third chunk, or something like that. So it's more granular, and it allows more granular optimizations. And I think with the with the performance of Webpack, I think we wouldn't be able to do that by like we couldn't scale the module graph by factor 10 or 20 or something. I think that would just like make it really so.
So, does that mean that some of the more core technologies are being rebuilt as part of this too? Because one thing that I I found out while doing lots of bundle trimming myself is that Webpack itself isn't doing a lot of the dead code elimination. A lot of that responsibility falls to Terser. Does the thing you just described kind of like replace the need for Terser, or are you guys going to like develop an alternative to Terser, or what's the story there?
Yeah, so it's like the current tree shaking. So dead code animation is mostly a minimizer job, but tree shaking is like a combination of removing unused exports and dead code elimination. So basically removing them, and then the other things are no longer referenced, and then dead code eliminated. And yeah, it's true that like most of the dead code elimination is in Terser, and Webpack only does basically removing the export. It's actually not really removing export, it's only removing the export keyword, which makes it like a variable declaration which is unused, and then that code elimination will like get rid of it. And we are still like relying on, so we didn't, so actually it's like more the future because we didn't implement production mode yet. But in the plan is that we still rely on the minimizer, but TurboPack is also more integrated with the minimizer. So we're using not Terser because Terser is JavaScript based. We're using SWC, which basically we as Vercel worked on like a few last years to make it like as compatible as to Terser as possible for minimizing. And so basically we rely on an SWC, and TurboPack is also really more deeply integrated in SWC is more deeply integrated into TurboPack. We use all the AST transformations and kind of stuff, and we implement transforms for SWC and use SWC for code generation. So we really heavily use SWC, and I also expect that we more deeply integrate with the dead code elimination of SWC, because currently it's like the current approach of Webpack, like removing unused exports and then dead code elimination, that works finish in most cases, but in some edge cases where you have dead code that spans across multiple modules, maybe then it can't really handle that, because it only looks like probably a function that contains some code, like one module, and then SWC can't see the connections between modules that are basically implicit through require statements and stuff like that. And so it's missing some opportunities to optimize, and with like the TurboPack future approach, we hope that we can like get like this kind of graph more integrated with dead code elimination, maybe making combined parts of both, and like getting more out of dead code elimination for TurboPack and for SWC.
That sounds super cool.
Yeah, funny.
So a large part of what powers Webpack is the ability to control what happens with loaders and plugins. Will TurboPack have a similar setup? Will it have a similar structure with its plugins?
Yeah, so our plan, so TurboPack is written in Rust, so you might expect that we only offer Rust plugins, but we didn't choose that way. So we want to offer JavaScript and Rust plugins, because we think that like making Rust the only platform of writing plugins would hinder a lot of adoption of writing plugins. And I think the most plugin authors are probably writing them out of their own use case in a web application. So they're probably familiar with JavaScript and TypeScript or whatever. And they just can't learn Rust just to write a plugin for a bundler. They want to use their edge case or the special case in their company and just solve them with a bundler. And I think giving people the opportunity to write JavaScript plugins or JavaScript-based plugins is much easier for people to get started with writing plugins. Even if the trade-off is that JavaScript plugins might be a little bit slower than Rust plugins. But I think in most cases, like 95% of plugins, it probably doesn't matter, because like the plugin is only evoked 5 times or something, and then it doesn't matter. Or in many cases, the people don't really care. It's more like they want to solve this problem, even if the build like takes 10 seconds longer or something. It's a trade-off. You can like write the plugin faster, but maybe you lose some performance. But I think that's a fine trade-off to do. And in the end, if you later discover that your plugin code is slow because you've written it in JavaScript, you can still port it to Rust or pay somebody to put it to Rust or like open source it, and hopefully somebody migrates it to Rust. So I think it's really important to offer JavaScript plugins or TypeScript plugins or whatever kind of language they want to use.
Yeah, that's awesome to hear, because I like the idea of fast plugins, but I don't like the idea of me having to learn Rust every time I want to write a little one-off thing that just adds a little thing to my build.
Yeah. Rust is actually, but Rust is really hard to write. It's like, if you like, I think there's also like a good idea to write your plugin in JavaScript first, because you can iterate fast on it and like develop it, and then maybe in the end you migrate it to Rust, even if you already familiar with Rust. And it's still like a good idea. Like Rust is much faster than writing and prototyping and like iterating on it compared to Rust.
Yeah.
It's like it's more safe and more fast, but there are trade-offs in languages.
But as you said, like most of the time, like you're not going to be writing something that executes for every single file. Like that's like those things can be relegated to Rust and be really, really quick. But everything else is like you're probably only doing one tiny thing.
Yeah. So in most cases, that's fine.
Will there be extra work to provide the plugin API surface for both JavaScript and Rust, or is there like some way you can automatically do that?
Not sure yet, because we didn't write it so far. But we have this interface. We need the interface to JavaScript anyway. So like for example, current cases, we want to read Next.js config. But Next.js config is not just a JSON file. It's like Node.js module. So we have to execute it. And so we need the same like infrastructure to like, here's some Node module that you want to execute some code of that, and we want to track all the dependencies and like basically all that stuff. So we need the infrastructure, and we already have it because of server-side rendering. This basically the same technology. We want to execute something in Node.js and watch it and all the dependencies of that. So we need that, and we have that, and we can use it to write plugins too, and then I think we are fine with that. So it's probably an extra cost, but we're willing to take that.
Yeah, that's awesome. The Rust bridge will be interesting. I've been writing a lot of Rust myself recently, and also playing a lot with Dino. And yeah, I don't know. The native bindings are always an interesting journey.
So currently we just like spawning a Node.js process and communicating with that. I'm not sure if it's days where we have more native binding kind of way. There is an overhead of serialization between Rust and JavaScript, and we discovered it hit by this hardly by integrating SWC into Webpack, and basically SWC is super fast in parsing this file in Rust. But if you want to serialize that AST to JavaScript, it's really huge cost, and it's like then in this case it didn't even it was not even worth to like serialize the AST compared to just parsing it in JavaScript. So it will be like I think we look into that, and we also like with also our performance goals, we also have this. Build up some tools to like get more path profiling information, get more insight into the like performance. So we trying to visualize this kind of overhead of like JavaScript invocation, also for the user, because if you write a plugin and you should know if it's fast or slow, and you should know or at least we should give you the insight to know which plugin is the slow part of your build and which should be ported to Rust or like improved or whatever. So that's hopefully really helpful in doing all this stuff.
Yeah, the serialization thing is a pretty common problem. I've always kind of wondered, and this is a little bit off topic, but I've always kind of wondered if SIMD would maybe unlock some of that. Like if there's some way you could use that creatively to like reduce the serialization problem, but maybe that's a topic for another time.
Yeah, I think there's some JSON paths with uset and yeah. I think that also like the main Rust JSON parser uses it, and it's pretty fast, I think. Yeah.
So, now we've talked about like what TurboPack is, but the naming scheme kind of piques my interest a little bit. So Vercel also has a project called Turbo Repo. Does TurboPack relate to Turbo Repo in any way other than just the name?
A little bit, yeah. So at least it shares like the principles of TurboRepo. So TurboRepo has this idea on a higher level where you have this graph of computation of tasks, and then you basically, if something invalidates, then it follows this graph of invalidation. And the engine behind TurboPack, the Turbo engine, uses this kind of same principle of having a graph of tasks and then following the graph for invalidations to make them like independent of app size, but on a really more granular scheme. So it's really like, while TurboRepo is like each task is one script execution, basically in npm script execution. In TurboPack, it's like one task is like a function in Rust, which is like really fast, like microseconds or something. And so like if you want to like feel the scale, it's like for one module in TurboPack you get like 200 tasks in the task graph of the incremental compilation engine. So it's really much more granular. And currently they share the name obviously, but also like the ideas, but they don't share a lot of code. But the vision is to get TurboRepo use the Turbo engine to basically use the granular execution incremental engine for their own execution. And then the vision is that if you use TurboRepo on monorepo scale and invoke like a Turbo engine powered task, like maybe Next.js or something, then it can basically share this graph. So basically you get one graph of executions for the monorepo scale, but down to like function level in TurboPack. So we have this really one graph for everything, where you basically, with the idea that you can make really fast incremental builds, like down to module level caching of TurboPack, but also like larger graphs tasks like TurboRepo. Hopefully making builds faster. Probably making builds faster.
That's a cool vision. I hope to see you guys realize it.
Yeah, I think we will do that. Yeah, it's also like there are some other things we want to share. Like TurboRepo has this remote caching kind of theme where you can like upload the cache result to the cloud and then share that with your coworkers. And we basically want to have the same for TurboPack. So if we have this task graph of all the granular executions and it's basically the cache, and we also want to upload that to the cloud and like get the same benefits where this module has already built by your coworker and that you can just download it and then you don't have to compile it. And it's very likely that you share a lot of modules with your coworker because we probably operate on the same code base, and then you can like have a lot of benefits about remote caching. And we want to go even further with some cloud computation things where you have this kind of same coworker sharing with like public caching, where you basically can trust the cloud, and then you only have to compute like the transformation or all this TurboPack stuff for modules that you share with the whole internet, like npm modules, which basically only one person has to like compile the node module, npm module, and that would be like the coolest vision. But it takes a while to get there. and we have to like implement a lot of features like before starting with that. But yeah, that's the larger vision.
So TurboPack sounds really exciting. It'll be really cool to see all the new improvements that can come out of that. But it sort of begs the obvious question of what's the future of Webpack and its maintenance?
Yeah, so the good thing is that like Webpack 5 is really stable and it doesn't need a lot of like urgent development that really like fixing bugs. So it's really it barely had 10 years of getting really stable, and so it doesn't need that much maintenance if you don't want to push a lot of new features into that. And I think at least it will stay maintained for probably at least 5 years, because it will be in use for maybe more than 5 years, or probably 5 years or more. So there will be maintenance, but I think there won't be like super huge much feature development, at least from my side. I will concentrate on getting like TurboPack mostly on the same state to Webpack, and our Webpack plan is that we've already like announced that we plan to make TurboPack a successor of Webpack. So it's like we plan to make it a migration really easy for Webpack. We plan to support many, probably all of the Webpack features. We also plan to support like just running Webpack loaders in TurboPack. So there will be a lot of compatibility between them. So in the end, if maybe in 2 years or 1 year, when we have like a good migration story from Webpack to TurboPack, maybe even earlier, then you can easily switch between them, and hopefully like this works for you. And even if not, Webpack will be maintained for at least 5 years or so, and I'm pretty sure it will be in use for at least 5 years, because companies are usually really slow in adopting new technologies. Yeah, but we try to make it really easy.
Well, that's it for this week's episode. Remember, the full episode is only available to our Patreon members. Thanks for coming on, Tobias. This was an awesome conversation. I've been a huge fan of you.
Yeah, thanks for having me.
I've been a huge fan of you since like getting into open source software. So to have you on here has been a real treat for me. So thanks for coming on.
Yeah, thanks for inviting me.
Yeah, I think just to echo what Andrew said, you've been such a tremendous impact in the community. It's like, one of my, basically how I really, really got into open source was not until I discovered Webpack and started like writing my first like Webpack plugin and like digging in at how Webpack plugins worked. And like, I gave a talk about that, and that like sort of like propelled my trajectory in the city. So yeah, I just like, you've had a tremendous impact on the whole ecosystem, and yeah, just thanks. And it was such a pleasure.
Yeah, thanks.